demoting you a level.
Well, you're on level 0 now.
All right. Let's kind of go over some things that lead up to what we need to be able to do today. Okay? If I give you the equation or inequality, x squared minus 9 is less than 0. How would you solve this? Okay, I don't know if you remember. We changed it to equal, and we said that x squared equals 9.
Yeah.
So x is plus or minus 3. I set up my intervals, negative infinity to negative 3, negative 3 to 3, and 3 to infinity. And I checked each interval to see what worked. You remember this?
Yeah.
Good.
This is an overview, right? Just making sure.
So what works?
Well,
I'm going to say negative 3 to 3.
yeah, that's good.
Yeah.
That's what works. So you remember how to do that kind of problem.
So that means that negative 3 to 3 would be... Oh.
Just like a long time ago.
Okay, if I give you the guys, we're moving on. We're not stopping and missing about everything here. If I give you this problem, what is the domain? Is there anything x can't be?
0.
Why?
No, that's 2 squared once.
So the domain is negative infinity to infinity? Right? Okay. Moving right along. Just kind of touching on some things you need to remember. All right? If y equals 4 minus x squared times e to the x, I want you to find the horizontal asymptotes. That's where it's the derivative has to equal 0, doesn't it? So what's the derivative? Is this a product? The derivative is the first times the derivative of the second plus the second times the derivative of the first.
Man.
Right? How am I going to set this equal to 0?
That's a really good question.
Well, I'm going to get rid of my parentheses first.
Yeah. Take them out.
So I have 4 e to the x minus x squared e to the x minus 2x e. Didn't mean for that to do that.
Amen.
E to the x. All this equals 0.
Yeah.
Can I factor out an e to the x?
I would totally agree with that.
Which leaves me 4 minus x squared minus 2x.
That's cool.
Any ideas? It will factor, but would I be better off to pull out a negative?
Yeah, probably. I would actually completely agree with that.
Gives me x squared plus 2x minus 4. Right? How am I going to solve? This can never equal 0. How am I going to solve this? I would, holy smoke. Because negative 2 and 2 doesn't work. I would poly small. Negative 3 point what? Is that it?
And 1.236.
And what are these? These are the x's where it has a horizontal tangent, right? Y'all remember this? Bless you. All right. Just making sure you remember it. Now, I'm going to give you guys a sheet of paper.
Totally.
Uh-huh. And on this paper, we're going to work a problem all the way through. And I'm giving you this paper because I want you to use it to take notes. And by the way, I've sent the paper to Jensen. Jensen has the paper.
Good.
So she's with us on this, if she wants to be.
That'd be terrible. That's great. We're going to put this in. It's probably going to make it so easy because she's on level 9 already.
What?
It's already on level 11.
Okay. On a sheet of paper, we're going to do this problem. You are given f of x,
Okay.
right?
Yep.
All right. What is the domain?
Negative infinity to positive.
Yeah.
I disagree.
No, it's 0, because it can't equal 0.
Why can't it equal
And
zero?
negative 3.
Why can't it equal negative 3?
Is this a square root of x? Is it a square root of x?
Greater than negative 0.
So x has to be greater than or equal to 0,
Yeah.
right?
But if it equals. Oh, yeah. Okay.
So that is your domain. Now, wasn't that hard to figure out, was it? You can put x is greater than or equal to 0, or you can put bracket 0 to infinity. All right, either one. Range, we will do at the end. We always do range at the end. All right. Now, where does it have x-intercepts? When a graph crosses the x-axis, what is y? 0. So to find the x-intercepts, I set this equal to 0. All right? So that means that x to the 1/2 equals 0, and x plus 3 equals 0. Do you agree? So does x equals 0 and x equals negative 3? Okay, you're making notes on this paper. Those are not x-intercepts. X-intercepts are points. They are 0, 0, and negative 3, 0.
Why 0?
The x
No,
plus the
we
y.
plug it if we plug that in for x.
Didn't we say that y would be 0? So what are your x-intercepts?
0, 0, and negative 3, 0.
I would write down under x-intercepts must be points. This is your notes, so when you do this, you're going to know what to do. All right? Now, y-intercepts. For a y-intercept, what is x? 0. So a y-intercept also must be a point. And it is 0, 0. Do you agree?
Because it's the same. Yeah. Yeah, I completely agree with that. It makes sense, yes.
Okay. We're moving on. You understand the intercepts are both points. The next line is f prime. What is that? So I want to take the derivative of this. Now you don't have a work area out there, don't you, where you can do it? The derivative of this is the first times the derivative of the second plus the second times the derivative of the first. Right? Do you agree? So is the derivative x to the 1/2 plus x plus 3 over 2 radical x. Agree or not?
Yes.
All right.
Yeah.
What's next?
0 for what x?
What?
Now we put it equal to 0, I think.
What does the next line say?
0 for what x?
Does it say 0 for what x?
It does.
Yeah.
It says f prime equals 0 for what
Oh,
x?
yeah, that makes sense.
Doesn't it?
Yeah.
So I set my derivative equal to 0 and solve for x. When I do that, do I have x plus 3 over 2 radical x equals radical x? Oh, excuse me, negative radical x. Is that what I have? How do I solve this?
Multiply.
Cross multiply?
Yeah.
Would you agree?
Mhm.
So negative 2x equals x plus 3?
Yeah.
Negative 3x equals 3. X is negative 1.
Wow. Okay, math is weird.
So we answered that one? Did you make notes so you'll know how to do it?
We have to make, should we just put,
You don't have to do anything
I was thinking,
unless you want to remember tomorrow. Yes, Luke?
For the f prime x, can we just put in x to the 1/2 plus x plus 3 over 2 radical x?
Yep. Now what does it say? When is f prime undefined? When is this undefined?
When x equals 0.
When x equals 0. There's your answer. It's undefined at 0.
Is it,
how do we know that?
would it not be undefined for when x equals anything less than?
Well, we've already established that in our domain. It can only start at 0,
Okay.
right? What was your question?
How do we get 0?
Well, what happens if 0 is this? Here's my derivative. What happens if x is 0?
Oh, okay, okay. That's,
That's just regular math, right? What's next? Where is it increasing? How did we do this? Just like we did yesterday, didn't we?
so we found the derivative already, and then set it equal to 0. We got the intervals, we make the intervals.
So what's my interval? No?
Negative,
No, my domain didn't start till 0.
0 to infinity. That's our
Okay,
one.
so my interval is 0 to infinity.
Because
This
negative.
is just what we did yesterday, isn't it?
Yeah.
Mm-hmm.
So pick a number,
1.
put it in the derivative,
Ah, shoot.
make notes that you need to make notes here, put it in the derivative,
Plus 4 over 2. 1 plus 2, 3. Positive.
so what's next?
Decreasing, so none.
It's increasing
Yeah.
from 0 to infinity. And by the way, increasing and decreasing always gets parentheses, because at the endpoints, isn't it not doing either one, it's at 0? So it always gets, so it's increasing from 0 to infinity,
Would you just say about parentheses?
it always gets parentheses.
When it's
Decreasing or decreasing,
okay.
because at the end it's 0, so it's not doing either one.
Oh, okay. I see what you're saying.
So we're good with that?
but-
What's next?
Decreasing, so none.
Wait a minute, it's only increasing, it's never decreasing, okay, what? By the way, do not leave it blank.
No.
You can put never, you can draw a line through it. But you leave it blank, it is assumed you didn't know, or didn't do it. So now, a local max or a local min. You know how to find that?
I have forgotten.
B minus f of a.
No,
This is where we find the critical points, right?
In
Yeah,
gravity.
find
If
the
it's
critical point.
increasing the whole time though.
it's always increasing. So it's never going to have a max or a min.
Yeah, no, it's true.
So then that
How would we?
I mean, it'd have a minimum, wouldn't it?
For a max or min, actually, we're going to have one. If it's always increasing, what is it doing at f of 0?
It's at
nothing.
zero.
It's minimum.
What value? It's a minimum.
Zero. Yeah.
It's a minimum at f of 0. Anywhere there's a critical point, it's a minimum or a maximum.
Yeah.
The only one we came up with was 0. What is f of 0? 0. So is the point 0, 0 a minimum?
Yeah.
Right?
Yeah.
So 0, 0 is a minimum. There is no maximum.
Now F2 prime.
Woo. Right?
Oh yeah.
Yes.
Everybody okay with that?
Actually, yeah.
So now let's go to, before we go on, before we go to the next one, are you all listening?
Yes.
Do you understand if it's increasing and then decreasing, it's a max?
Yes.
If it's decreasing and then increasing, it's a
Min.
min. You all understand that?
Yeah.
All right. F double prime. Oh. So I've got to go to this right here and take the derivative.
Yes.
Where,
To x
Hang on.
1 half plus x plus 3 over 2 radical x.
Tell me what y prime is.
y prime is x to the 1/2 plus x plus 3 over 2 radical x. Over 2 radical x. All over 2 radical x.
2x to the 1/2. Can I do that?
Yeah.
All right. So, how do I take the derivative?
You got 1/2 x and 1/2.
Hang on. Plus, isn't that
Quotient.
a quotient?
Yes.
And the rule of the quotient is the bottom
Baby toes minus
times the derivative of the top, which is what?
1.
Minus the top. What's the derivative of the bottom?
X to the negative 1/2.
Negative a. Wait, no, what am I
Over.
And just the bottom square for x. Yeah.
Oh, that was nice. Right? Okay, I can't leave it like that.
Oh, I disagree. I don't care.
So this is 1 over 2 radical x plus this is 2 radical x minus x plus 3 over radical x all over 4x. Right? Think that's worse?
Yes.
Oh no.
We find a common denominator, maybe. Or no.
Why did it become? I'm just. No, forget.
I would personally like to find a common denominator.
I'm going to. I'm just letting everybody get caught up. Okay, for this fraction right here, I'm going to get a common denominator. What's it going to be? Radical x. So do I have 1 over 2 radical x plus, isn't this
Just 2x.
2x
Over radical x.
minus x minus 3 over radical x over 4x?
Why did your sign change next plus 3? Or next plus 3?
I distributed this negative through there. Are you with me?
I am completely with you.
Wait, can we multiply?
We just multiply that.
Well, I'm not going to do anything till I clean it up. All right? So I have 1 over 2 radical x plus x minus 3 over 4x radical x.
Why is the 4 down there and not on top?
That's cool. I don't like that. Are you just legally allowed to do that?
Well, isn't this fraction divided by 4x,
Yeah,
which is times 1 over 4x,
yeah.
Okay,
right?
So why is there 4x in the bottom? Shouldn't it be 2x in the bottom?
No.
Then where'd the other 2x go?
Oh, 2x minus x.
Oh, okay. Wait. Oh.
Now, common denominator of what?
Wait.
Okay, so we just multiply it by 2x. Then that one side by 2x.
4x radical x. Right?
And we have
What am I going to multiply this by?
2x
So I have 2x.
plus x minus 3.
So I have 3x minus 3 over 4x radical x. And this is my second derivative.
That was unfortunate.
I don't like that. That was pretty terrible.
What's the next row?
0 for what? F? F double prime x. 0 for
When is this equal to 0? It is equal to 0 when my numerator equals 0.
So x is 1.
So x is 1. There you go. What's mine? You okay, Emma?
I'm getting there.
Why do we specifically set the numerator equal to 0 on that
Because
one?
when is something equal to 0? When the numerator is equal to 0. If the denominator equals 0, it's undefined.
We do that.
Yeah, we did.
Okay.
All right. What's next?
If it's a negative number,
Prime
f is a
F
prime
is undefined for what number?
Well, for what is f double prime undefined?
0.
0.
What about if it's a negative number? That'd give an
Our domain was 0 to infinity.
Sure, I didn't think about that.
That's why we set the domain at the beginning. Now, where are we?
Concave up.
Concave up is this. Does that make sense? Concave down,
This
y'all are not listening. Concave down is this. Do you all agree?
Yeah.
Okay. When it is concave up and concave down works just like increasing and decreasing for the first derivative. But concave up and concave down is now second derivative. If second derivative is positive, it is concave up. If second derivative is negative, it is concave down. Okay? Does that make sense? So I'm going to set up my intervals, which are 0 to 1 and 1 to infinity.
Where do you get the 1 from? Okay.
When I set this equal to 0, and I set x equal 1, didn't I?
So then we just,
Done that for the other one too?
Well, we didn't.
there was
No, it didn't equal 0.
It was negative 1.
It was negative 1, which was in my domain. So do you understand where those intervals came from? They come from where it's equal to 0 and where it's undefined. That happens for first derivative, that happens for second derivative. Now, pick a number between 0 and 1. What are you going to pick?
A half.
So when I put a half in here, what do I get? Positive or negative? I don't care what the answer.
Positive.
Positive.
I don't.
No, it's negative.
It's negative. Right? What do I put here? 2? And it's positive?
Okay, yeah, that makes good sense.
Wait, hold on. Are we plugging that into the original or
To the
no,
second
the
derivative.
second derivative? Okay.
That's why it's under the second derivative.
I got you. Okay.
Are you all with me? Now, it is concave down from 0 to 1. It is concave up from 1 to infinity. Right? What's next?
These ones also all parentheses.
Has inflection
What?
point.
But it's also parentheses.
Yes. Second derivative works the same way first derivative works, only with concavity.
Has inflection point.
Inflection point is where it changes concavity. It has to go from up to down or down to up. The only x value that happens at is what? 1. So 1 is my x value. Inflection is a point. Has to have an x and a y. If x is 1, what is y?
We put this into our double derivative.
How do you find a y value?
Oh, in the original.
The original is y equals, isn't it? So I go to my original, and I plug for x, I plug in 1.
You get 3.
You get 3?
No?
We got 4.
Wait, what did we do?
Oh wait, yeah, no, you do get
X
4.
was 3.
Yep, you do.
4?
Yes.
Did we get 4?
Wait, we plugged
Yes.
1 into.
Original.
So the inflection point is 1, 4. Agreed?
So do we plug in what we got, the second derivative equal to 0 for?
Yes. I did process what you processed.
Yes.
Okay, now we need to graph this.
So we're, on this, we're not using the f times a minus f times v.
That's
No.
the secant line.
I'm going to graph it. Tell me every point we have.
0, -3.
No, 0 is not a point.
0, 0.
0, 0. What else?
-3, 0.
What else?
1, 4.
Wait, negative.
Right?
That's all I can see right now.
Now, something's wrong.
That's all the points we have.
He said negative.
Wait, how do you do
0,
that?
it's negative 3.
It can't be negative 3, 0.
Because of the domain. Yeah.
That's what. Now, doesn't this say that the graph is always increasing?
Yeah.
Then it also says it's concave down until 1 and then concave up.
Yeah.
So I would say the graph is going to be concave down and then concave up.
But wouldn't that be a local max?
What? No?
It doesn't start
Looks,
going
it
down.
doesn't, yeah. It doesn't
You
kick
agree with
down.
what that looks like?
Yeah, that makes sense.
Yep.
Now, before the bell rings,
The range.
what is the range?
0 to infinity.
0 to infinity, by looking at the graph.
Where'd you go?